All right, good morning, everybody, and happy April 1st. All right, so officially we're not coming back to school till May 4th, so we're going to be trying to adapt. They're not going to let y'all in the building till then, except to come in one at a time and get your work. So what I'm going to do is start posting the free response questions I'll send them by email and I'll send them by Remind, and then I will give you the scoring sheets to go with them. If you are taking the test, please score yourself very critically. In other words, if you don't get the right answer, you don't get the unit point. So if you, I don't know, let's say it's oil. So if you get 504 gallons and that's wrong, then you don't qualify for the gallon point. So you have to get the answer right and then the other point. So again, the more harshly you score yourself and the tighter you make your answers, the better you're going to do in the end. The other thing I was going to ask you guys is whether you have gotten this review. And it's rather lengthy, and I'm not sure if I sent it out, but if not, I'll put one up I'll scan it and put it on. This is the purple sheet. Of course, it's white today. But this is everything that we've done all year. So it basically breaks everything down, limits as x approaches c, as x approaches infinity, piecewise limits, whether our functions are continuous, intermediate value theorem, IVT, the corn growing in the meadow. You can't get to from 3 to 10 without going through every number in between. Average rate of change, just slope, you know that. Instantaneous rate of change, difference quotient, formal definition, horizontal, vertical, non-differentiable related rates. Then it goes on. Linear approximation. Remember, all you're going to do is your slope of your tangent line and then plug in the value you're trying to approximate. Rate of change, MVT, etc. Speeds up, slows down. This one is always tricky. Velocity and acceleration have the same sign. Speeding up, velocity and acceleration have different signs. Slowing down. Derivatives. First d second, second d first. Then it goes on to your trig derivatives. Easy enough. The derivative of the inverse, that always fuzzes us up, so be sure you study that. Derivative of e to the u, Riemann sums, left, right, or midpoints. Integration, x to the n, the summation bar, which is your integral, FTC, average value, again, don't forget that. And then it takes us into fundamental theorem of calculus part 2. G of x is the area under the curve, G derivative is the curve, G second derivative is the slope of the curve. Total distance traveled, absolute value. Displacement is just your velocity, integration. Now, these last areas, the area, the revolve, the cross-section, you won't be responsible for any of that on this exam. They're leaving that section out knowing that the time constraint is what it is. All right. So what we're going to do today is start with the quiz that I gave you the other day. And these are the answers. So let's see how we did. Pretty straightforward off the first. Antiderivative of sine, antiderivative of cosine. Again, when you're getting ready to take this test, it only takes seconds to write all your trig functions and all their derivatives. That way you're not switching back and forth in your brain. You've got it, you can refer to it, and it only takes a small amount of time. So go ahead and be sure you do that. All right, nothing really tricky here, pretty straightforward. That all should have gone fairly well for you. Now on the back, here we go. Remember, we've got these 5 slope fields here, yay, and we're trying to figure out which equation goes with which slope field. So the very first thing I did was I looked at, this is dependent on y, this is dependent on y, this one's dependent on x, dependent on y, and dependent on y. All right, so I started with problem 11 because I know my x equal line I do that every time, is this. So since I'm dependent on x and not y, I'm looking for the slope field that has all the same slopes vertically. And just let me look at D here. So if I'm looking at problem D, the slopes clearly are changing as I go vertically. If I'm looking at A, the slopes are changing as I move vertically. The only function that has all the slopes the same vertically is E. So I rule that out right away. The next thing I'm looking at is I moved over to 13 because it's a y-square function, and I know that all my slopes are going to be positive. So again, I'm looking through the slope fields. A has negative slopes, B has negative slopes, C has negative slopes, but D, all my slopes are positive. Then after that, it's just sort of filling out the, it's just filling out the tables. The biggest problem I had was between A and C for problem 10 and 12. But I know that this is y by itself, and this is 1 over y. So this is going to be more steep than these are going to be. In other words, if I'm at 0, 10, then 0 doesn't matter, the 10 matters, the slope is 10. But if I'm at 0, 10 on problem C, then I've got 0 over and 1 over 10, 1/10. So these are going to be much steeper than these slopes are, and we go from there. I know that's a little bit tricky, and if you have questions, you can text those to me on the Remind app. Okay, we want to look at, well, let me come back to that. I don't have the homework over here with me, so I'm going to turn you loose with a couple problems that we're going to write out, and then we're going to move into the review, and I'll get the homework answers in just a minute. Let's start with problem number 1. You have an investment, and it's growing at 1.5%, compounded continuously. Now that matters because that puts us into a very special equation, the PERT equation. So if you invest, let's say $125, how long until you have $200? And you will need a calculator for this question. So what you need to recognize on this question, the compounded continuously puts you into this equation. Or if we're talking about money, it's usually principal at time 0. Principal at time t is principal at time 0 e to the RT, the PERT equation, which we've looked at before. So what do you know? Well, you know what you want at time t, which is 200, and you know how much you're starting with. E is a given. The rate of return is 0.015, and t is the variable we're looking for. So that's what's missing out of all of this. All right, take just a minute and solve that, and I'll be right back. Okay, I want to know about my homework. So you should be at 31.333 years to have your investment grow from 125 to $200 at 1.5%. Okay, fairly straightforward. The hardest part of that question is recognizing when it says compounding continuously, you've got to head straight to that PERT equation. Okay, here's a question that I really like. It's on your review. It's on your test, so here we go. What is an equation of a curve that intersects at right angles What's the equation of a curve that intersects at right angles every curve of the family y equal x cubed plus some constant? What is the equation of a curve that intersects at right angles every curve of the family y equal x cubed plus k? And I don't think y'all have seen anything like this before. So where do we start? Well, first of all, it intersects at right angles. If I'm intersecting at a right angle, my lines are perpendicular. And that's a big clue to solving this problem. All right, well, if they're perpendicular, they have negative reciprocal slopes. Ah, okay, well, so what's the slope of this family of curves? Oh, yeah, the derivative. So the slope of this family of curves is 3x squared. Now remember, it is 3x squared over 1. So my family of curves, my perpendicular slope then, is going to be, and I'm just going to call it z, negative 1 over 3x squared. There's my negative reciprocal. Well, how do I find the family that that comes from? All I have to do is integrate it and work backwards to the family of functions. So this is kind of a tricky question. It looks very innocent, but it takes a lot. You have to know that if you're intersecting at right angles, you have a perpendicular slope to the curve that you have. You have to know to find the slope of the curve of the family you've been given, and then set it negative reciprocal. Okay, so I'm going to take the negative 1/3 out, and I'm integrating x to the negative 2 dx, which of course, if you add 1 to it, is going to give you negative 1/3 times negative 1 over x. And then it's indefinite integration, so we're going to add the c to it. Negative times negative is positive, so my curve called the z family is going to be 1 over 3x plus c. Sometimes the more innocent the question, the trickier it can be. All right, let's go back and revisit our u sub. We haven't done this in a while. We're going to evaluate this integral in u sub. So we are integrating from 0 to 3 pi 4. We're integrating e to the tan x over cosine squared x dx. Okay, so it's a little bit tricky here because our choices for u are if it's embedded in a function, well, cosine's embedded, something squared. If it's a denominator, well, then I've got cosine squared, and if it's a power. So you kind of have to think your way through this. And what's the, we haven't talked about this in a while, so remember we have sine, derivative cosine, cosine negative sine, tangent secant, secant squared, cotangent negative cosecant squared, secant, secant tan, cosecant negative cosecant cotan. All right, so if I use the something squared, then my derivative is going to be 2 times the something, and that's not going to clear anything up. If I use cosine, my antiderivative, or excuse me, my derivative is going to be sine, and that's not going to clear anything up. But what if I make tangent my u? Well, the derivative of tangent is secant squared. And remember, secant squared is 1 over cosine squared. So there you go. So we're going to make u tan x. So now I'm integrating from 0 to 3 pi 4 e to the u over cosine squared x dx. Okay. Du is going to be secant squared x dx, and there's secant squared x dx right there. So now I'm integrating from 0 to 3 pi 4 e to the u du. Of course, the antiderivative of e to the u is e to the u, so I'd like to stay in the u sub, so I'm going to need to change my limits of integration. My lower limit is 0, and if I run it through the u equal, the tangent of 0 is, remember, tangent, I know it's been a long time, is sine over cosine. So I have 0 over 1, I have 0. The tangent of 3 pi 4, second quadrant, negative 1. Okay, so we come back over and we're going to use our new limits of integration. So now I'm integrating from 0 to negative 1 e to the u du. Of course, this is a problem. So we're going to flip it and multiply by negative 1. All right, so here we go. We have e to the negative 1 times. The antiderivative of e to the u, of course, is e to the u, and we'll be evaluating that from 0 to negative 1. So I have negative 1 e to the 0, e to the negative 1. And don't go weak right now. You got to keep going. We have negative 1 times e to the 0, any number of the 0 power, and e to the negative 1 is 1 over e. So our answer is negative 1 plus 1 over e. And it has been probably a long time since you've looked at u sub. All right. I guess it's been a month now. Let's talk about if we're given the equation x squared plus y squared, let's go with 49. So you ought to recognize that as the equation of a circle. The center is at 0, 0, and the radius, of course, is 7. All right. So the question is, evaluate the second derivative at negative 1, 1. That's the question. Given x squared plus y squared is 49, evaluate your second derivative at negative 1, 1. All right, hopefully you memorized when we talked about this the first time that the derivative of a circle is negative x over y. And that'll save you some time. But if you didn't, hang on, then if you didn't realize that, then you have 2x dx dx, 2y dy dx is 0, which of course gives you 2y dy dx is negative 2x, and dy dx is negative 2x over 2y, giving you negative x over y. So again, if you didn't memorize it, it's not a big deal. It's really easy to get to the derivative, the first derivative. Okay, so here we go. Now we've got to head to the second derivative. So my first derivative is negative x over y. So its derivative, the second derivative, is, I'm going to do low d high. So I've got low d high minus high d low. Now, the derivative of y is 1, but it is 1 dy dx. Remember, we're integrating, we're finding derivatives with respect to x. This is the most important part of this problem, because you're going to forget it. And then that's all going to be over low y squared. So low y, the derivative of negative x is negative 1 dx dx. The dx's go away. Minus high, negative x, d low, 1 dy dx. Now you're thinking, well, I'm stuck, except you're really not, because you know what dy dx equals. So you can go ahead and plug that in. So now I've got the second derivative is going to be negative y minus negative x times negative x over y, over low. Okay? And that's going to give me negative y minus x squared over y over low. So there we've gone from first derivative to second derivative, and we're being asked to evaluate the second derivative at negative 1, 1. Remember, this is your x, this is your y, and I don't mean to sound sarcastic saying that, but it's really easy to forget. So give yourself some road marks here. All right, so I've got negative 1. I'm plugging in 1 for y, minus negative 1 squared over 1 squared. All right, so I've got negative 1 minus 1 over 1. Please don't tell me it's 0. It's negative 2 over 1, or simply negative 2. Okay, those are some good problems for you to practice. And we are going to, I've got the answer key to problem assignment 79. So let me pull that up for you and let you look through that. You may want to take a screenshot or a picture. Here we go. Oil was being pumped continuously from an oil well at a rate proportional to the oil left in the well. dy dt is ky, where y is the oil left in the well. There were 1 million gallons, and 6 years later there were 500,000 gallons. It is no longer profitable to pump oil when there are fewer than 50,000 gallons remaining. Write an equation for y. So here we go. dy dt is ky. Separate. dy over y is k dt. Integrate. ln y, kt plus c. And that puts you immediately into y equal kt plus c, which puts your c to the beginning. Now we got to find out what the value of C is. And they told us that at time 0, we had 1,000,000 gallons. So C is 10 to the 6th, or ln 10 to the 6th. And then when you raise e to the ln 10�6th power, it becomes 10�6. So there's our equation, y equal 10 to the 6th e to the kt. Now remember, in these situations, you have to work it again to find the value of k. So you're going to do the same thing, base log base again. So when I divide, they're telling me at time 6, we're at 500,000 gallons. So I plug that information in here and here. 0.5 is e to the 6k power. Take the log of both sides. Natural log 1/2. 6k natural log e, the natural log e falls away, and k equals ln 1/2 over 6. When I plug that back in here, remember e to the ln 1/2, base log base, e turns into 1/2 t to the 6th. If you're not comfortable with that, practice that a couple of times. It'll start to make sense the more you practice it. So there's my equation for finding out what we've got. All right, at what rate is the amount of oil in the well decreasing? This is a little tricky. At what rate is the amount of the oil in the well decreasing when there are 600,000 gallons remaining? So they're asking you, what is the derivative? What's the rate of change? At what rate are we decreasing? So hopefully you realized you're just going to use the straight up equation that they gave us. And you've got negative 69,314. Okay. We found what the variable k was. K is ln 1/2 over 6. And they're telling us the y value, 600,000 gallons. And then it's just math from there. That's a little tricky because you're not used to going back to the derivative you've been provided. So that's a little tricky. If you didn't quite catch that, don't worry. Just practice and realize what they're asking you. In order not to lose money, when should oil no longer be pumped from the well? Well, remember, they told us that when we're at 50,000 gallons, we start losing money. So we go straight into our y equals CERT equation with that. And we end up with 0.05, 50,000 divided by 10 to the 6 is 1/2 t to the 6, or excuse me, t divided by 6 power. We're going to take the log of both sides. Now in this case, we can't get rid of the 1/2 because it's not e. So I've got natural log 0.5 divided by natural log 0.5 is t over 6. And we end up with 25.93 years. Okay, again, I didn't get any questions last night, but if you have questions, you're certainly welcome to text them on Remind. Okay, we're going to work a couple problems off the review that I think you might need a little refresher course on. Give me just a minute. I'm going to start out with problem number 1 on the review, and then we'll go from there. By the way, if you have your review and you've already started it, please note that you will be omitting problem 11 and problem 12. Those deal with area between two curves, and we're not going to do that. When we come back in May, you'll learn that so that when you head off to school next year, you'll at least have your complete solid foundation. But you won't be tested over that on the test this year, so we'll get to it afterwards. All right, problem 1. We are integrating cosine over 1 plus sine. And we're looking for its indefinite integration. Excuse me, we're just looking, we're just looking for the family of functions. So if it's embedded, if it's a derivative, if it's raised to a power, clearly we only have one of those situations. So that's what I've got right now. du is going to be negative hang on just a second. I'm sorry, I was doing the antiderivative. du is cosine t dt. I thought that looked funny. All right, so now I'm integrating u to the negative 1 du. Antiderivative of that is going to be ln u plus c. We have no limits of integration. We can't change our integration from t to u, so we have to plug back in. U is 1 plus, so there is my equation. That should be fairly straightforward. Okay, let's look at one that's a little more complicated. Let's look at number 6. I'm trying to keep track of my time. All right, problem 6. They tell me dr ds is e to the r plus s. This one gets a little tricky because you've got to figure out what's your x and what's your y, right? So historically, when you've been looking at derivatives, you've been looking at dy dx. And now they're saying dr ds. So I have an ordered pair x and y. And if I follow the same format, that means r is going to be my x value and s is going to be my... I just did that completely backwards. I'm sorry. S is going to be my x value and r is going to be my y value. Okay. Now, everything else works the same. I have e to the r times e to the s. Remember, we can separate if we're adding exponents. We're multiplying common bases. Now I'm going to get all my like terms together. So I have dr, e to the r, e to the s, ds. So r is y, s is x. It's hard to say. All right, we're going to integrate. Now, be careful here because e is not a variable. You don't have 1 over, your variable is not to the negative 1 power. The r is to the negative 1 power. Okay? So when you find your antiderivative here, you're going to be adding 1, and that's going to give you, and then you're going to have the negative 1 because you have... Do you understand what I'm saying? That's a little tricky. We haven't seen something like that before. And don't forget the antiderivative of negative r. So my antiderivative here is going to be negative e to the negative r. And that is a little tricky. On the other side, the antiderivative of e to the s is simply e to the s. And then, of course, we're going to have our constant of integration. Please be careful that you realize e is not a variable. I don't have e to the negative 1 power. I have e to the negative r power. And the antiderivative of e to the negative r is e to the negative r times the derivative of the negative r, which is negative 1. So be careful there. Don't look at e as a variable. E is a number. Okay, they've given us the situation that r of 1 is 0. So again, this is my x, my s, and this is my y, or my r. So I've got negative e to the 0 is e to the 1 plus c. Well, any number to the 0 power, of course, is 1, and it equals e plus c. So my constant in this case is, let's move that over there, negative 1 minus e. All right? A lot going on in this problem. So now when I come back up to what is the actual equation, negative e to the negative r is e to the s minus 1 minus e. It seems like I've got a sign in there, and I'll look at it later when I've got more time. If I do, I'll write back. Something's not quite clicking right with me. But I'll look at it in a minute. Okay, kind of a tricky problem. We have 10 minutes left. Let me move on. And I'm going to send you the key to the whole review. I just want to be sure we can run through some of these problems together. Let's try problem 7. It's a little tricky also. I have root x plus root y dy dx is 0. Now, we've talked about when we go to integrate with differential equations, we can't add or subtract, but we're not starting there yet. Where we're starting right now is let's just get the dy dx by itself. Okay, so I've got root y dy dx is negative root x. Now I'm going to separate, and all I have to do now is just multiply by dx, and that gets my y terms to one side and my x terms to the other. So I have root y dy is negative root x dx. So there's our separation. Now we're going to integrate. So I've got y to the 1/2 dy negative x to the 1/2 dx. Remember, you don't have to do this in your head. You can always just step aside and work it. There's no problem with that. So we have 2/3 y to the 3/2 is negative 2/3 x to the 3/2 plus a constant of integration. And I'm trying to remember what the initial condition here is. I think they gave me 1, 4. Yeah, they say that y of 1 equal 4. Okay, so we'll plug that in, that condition, to find the value of c. So 2/3 4 to the 3/2 negative 2/3 1 to the 3/2 plus c. Whoa, lost you. There we are. All right. So square root 2, 2, 4, 8. 8 times 2, I've got 16/3 is negative 2/3 plus c. c is equal to 18/3. All right. Remember, we're solving for y. So we go back into our equation with the value of c. So we have 2/3 y to the 3/2 is negative 2/3 x to the 3/2 plus 18/3. I'm going to get rid of the 3. I'm going to divide everybody by 2. I'm going to raise this to the 2/3 power. And I'm going to raise all of this to the 2/3 power. And so y is finally isolated, and it's negative x to the 3/2 power plus 9 all to the 2/3 power. And that is a lot. Okay, there is another one. Let's go look at problem 8. All right, so problem 8 is asking us to find the average value of 3x squared minus 2x on the interval 1, 2, 4. So they're asking me to integrate from 1 to 4, 3x squared minus 2x dx, and they want the average value. So remember, 1 over b minus a. There's your average value. When you integrate this, you're going to find the complete area under the curve, but they want the average. All right. So I've got 1 over 4 minus 1 times the integration from 1 to 4 of 3x squared minus 2x dx. So I have 1/3. My antiderivative, this seems almost too easy, x cubed. Is it seriously that easy? I get that, yeah, it sure is. After all we've been doing, that looks way too easy. 3x squared minus 2x, okay? And I'm integrating from 4 to 1. All right? So I have 1/3, 4 cubed minus 4 squared, 1 cubed, 1 squared. .48. So my area under the curve is 48 units, but my average is 16. Okay, I think I have time for one more. So let's jump over to problem, hopefully we can get this done. Let's jump over to problem 15. And it's another PERT problem. At any time, the rate of growth of bacteria is given by derivative is ky. So remember, we have dy dt is ky. And again, if you're using the variable x instead of t, that's not a big deal. Don't stress over that. The initial population is 1,000, so at time 0, I'm at 1,000. And the population doubles during the first 5 hours, so at time 5, I'm at 2,000. And that's important because remember, we're going to have to find our values twice. So I've got dy over y is k dt, ln y, kt plus c. By now, that should be fairly rote. So we're going to use our initial condition to find the value of c. So we know ln 1,000 is k times 0 plus c. C equals ln 1,000. And again, when you go back to e to the kt plus c is y. You have e to the kt, e to the ln 1,000. Your variable is 1,000, the value of c. So y equal 1,000 e to the kt, P-E-R-T. Okay, well that's great, but remember now we have to replace this e, and they've told us at time 5 our bacteria has doubled. So here we go, 2,000 e to the 5k. I almost wrote 5t. All right, so 2 is e to the 5k. So ln 2 is 5k. ln 2 divided by 5 is k. And when you go back and you plug that in, you have e to the ln 2 times t, base log base, this is going to turn into 2. So my equation is 1,000 2 to the t divided by 5. I think that is all the time we have. I will scan the workout of this, and then what I'll do is put the test online, and I'll put the answers to the test online Monday. We're not meeting again. Everything from here on out is going to be by remind and email. So I will I'll send you copies of everything we've done today, and I'll send you test 11, and then next week I will start sending out the free response questions in preparation for your exam. By the way, AP is meeting tonight, and they're going to decide on the date of the test, and I'll let you know all of that when I find out. All right, have a great day. Thanks, guys. Bye.